Yo, hi, welcome. Let's see how we're going to solve this Olympiad problem. So we have 2 to the power of x equals x to the power of 32. So how are we going to solve this? If you can solve it, kindly put the solution in the comment section. For those of you that could not solve it, so let's see how we can solve this together. Now I have 2 to the power of x equals x to the power of 32. So I want to be solving for the value of x that is just positive integers. Now from here, I'm going to introduce a natural log to the both sides. Ln 2 to the power of x equals ln of x to the power of 32. And you know that this is logarithm. Whenever you apply logarithm, so this power we have to come down, multiply, you have ln of 2. This 32 will come down, we have 32 ln of x. So now from here, so let's do a separable variable in the sense that, so let's try to connect x together and the numbers, all right, separately. So now this is going to be we have what we have, this can be x to the power of ln of x, all right, then this place will be ln of x. So you see that multiply by ln of 2, and this one also ln of 2. So you'll see that from here, ln of 2, we cancel ln of 2, we have x over ln of x, then equals here, this ln of x, we cancel ln of x, we're going to have 32 divided by ln of 2. So now looking at this, you can see we have what we have: constants on one side and we have variables on one side. So now let's see what we can do now. So can we write this as this? If you look at the left hand side, we have x here, which is happen to be the argument for this logarithm here. But here we have 32 and we have ln of 2. So now can we try to, let's manipulate so that we're going to have the same thing that is there will be the argument of the logarithm here. So what we're going to do is x equals divided by ln of x equals, now if I multiply this 32 by 2, all right, and I multiply this down one also by 2, all right, that is multiplication. Let me use this. So you know that we're going to have x over ln of x equals, now 32 multiplied by 2, we're going to have 64, all right. But here this 2 is multiplying ln of 2, and by doing so, you see that this can come, or they can go over this and raise to power 2. We can have ln of 2 to the power of 2. All right, you can see we're going to have x over ln of x equals 64 over ln of 4. I don't know, are you getting what I'm saying? So the same thing we are going to do, let's repeat the same thing. Multiply this by 2. I will multiply this also by 2. Don't multiply it by 2 here, because you think maybe it is 4 times 2. So we are multiplying 2 by this, so 2. Or if you want to do it, you can put the 2 here. We have 64 here already, so you can put 2 times here. So 2 times 64, now we're going to have x over ln of x equals 2 times 64, that's going to give us 128 all over. Now this 2 here, we also have to come down here. We have ln of 4 to the power of 2, and you know that 4 to the power of 2 will give us 16. So we are going to have what? We're going to have ln of 16. So now from there, the next thing we're going to do, let us go from here again. You can see that 128 is here and 16 is here, so we still don't have the same thing. So we're still going to multiply this and this by 2. We have x over ln of x equals 2 multiplied by 128 divided by 2 multiplied by ln of what? Ln of 16. And you know that we're going to have x over ln of x equals 2 times 128, that's going to be 256, then divided by ln of 16 to the power of 2. So now 16 divided by 16 raised to the power of 2 is going to give us 256. We have ln of 256. Then we have x all over ln of x. So now, according to what we have here, so look at this, the same thing. Look at this, the same thing. So we can compare that x equals what? 256. And that is the solution. Thank you so much for watching. If you enjoyed the class, kindly share this to your friends so they can learn from it. Bye-bye.